Hello everyone. Today we're going to discuss how to solve rational equations. Now, rational equations are a little bit different from fractional equations. Notice that in a rational equation, we have fractions, but the denominators consist of variables. And when we have a variable in the denominator, we should always be careful on the restrictions for the denominator. The denominator of a fraction cannot equal 0, and in this case, it's understood that x does not equal 0. It is implied when we write this rational equation. So rational equation is like a fractional equation, except that the denominators consist of variables. And to solve a rational equation, we solve it like a fractional equation. We get the least common denominator of the denominators. So the least common denominator for x squared, x, and 16 would just be 16x squared. And rather than having a common denominator of 16x squared, we're going to clear the denominators by doing the following. We're going to multiply each side of the rational equation by the least common denominator, 16x squared, which is understood to be 16x squared over 1. And we recopy our equation. And do you remember the name of the property that allows us to do that? The name of the property is the multiplication property of equality. So as long as we multiply each side of the equation by the same non-zero number, the resulting equation will be the same. Now, on the side with addition, we have to distribute using the distributive property of multiplication over addition, whereas on this right side, we just multiply two fractions. But note that when we do that, we get 16x squared over x squared plus 32x squared over x is equal to 16x squared times 9 over 16. And notice what happens. The denominator divides through. So in the first one, the x squares divide through. The second one of the x's divide through. And in the last one, the 16 divides through. So we could have written this step immediately. 16 plus 32x equals 9x squared. And this is called clearing the denominators. Now, if we rewrite this in standard form to solve the quadratic equation, the right side is factorable. It could be factored into 9x plus 4 times x minus 4, and we could quickly check the inner and outer terms, and we do get a negative 32x there. So 9x plus 4 could equal 0, or x minus 4 equals 0. So x could be negative 4/9, and x could be 4. This would be our solution set. We can easily check it by substituting into the original equation, and it would probably check as long as one of our solutions is not 0. Otherwise, we would have to reject it. Let's take a look at another one. Here is another example of a rational equation, except that this one's a little different from the first one. Notice that our denominators are binomials. So the first thing we should try to do here is factor. Factor as much as you can. It simplifies the problem. So the only thing that we could factor out here is the second denominator, which is the difference of two squares. So we'll factor it out. And this will serve two purposes. First, we see the restrictions on the denominator. Here, looking at the first denominator, y cannot equal negative 2. In the second denominator, y cannot equal negative 2 or 2, if we set each factor to 0. And in the last denominator, y is not equal to 2. So these are the restrictions for the denominator. Now, by factoring the denominators, we can see that the least common denominator here is just y plus 2 times y minus 2. So let's multiply each side by the least common denominator, and let's see what happens. using the multiplication property of equality again. And we'll rewrite this one in black. And again, this is understood to be 1 because we're multiplying both sides by a non-zero number. And when we distribute the side that has subtraction, I think we're ready to divide through as we distribute. So in the first product here, the y plus 2's drop out, so we're left with y minus 2 times y plus 3. In the second one, both factors drop out here, so we're left with minus y. And here we just multiply the numerators and denominators, but notice that the y minus 2's divide through, so we're left with y times y plus 2. So now we've cleared the denominators and we can easily solve. So if we multiply these out, we get y squared plus y minus 6 minus y. And here we distribute and we get y squared plus 2y. And combining like terms, we get y squared minus 6 equals y squared plus 2y. Notice that we could subtract the y squared on each side and they disappear. And we get negative 6 equals 2y and y equals negative 3. And that would be our solution set as long as we didn't get negative 2 or 2, which are the restrictions that we discussed last time. And we could substitute negative 3. Looking at the first one, if we substitute negative 3 here, we get a 0 for the first fraction. In the second fraction, we get the opposite of negative 3, which is 3, over 5. So that's 3/5. And when we substitute negative 3 here, we get negative 3 over negative 5, which is 3/5. So it checks. Let's go and look at another one now. Okay, this one I'd like you to try yourselves. The problem is 2 over x plus 3 minus 3x plus 5 over x squared plus 4x plus 3 equals 5 over x plus 1. Factor the denominator, list your restrictions, and solve it in a way similar to what we've done in the last problem. Pause the video and then restart. Okay, so let's take a look at the solution quickly. We factored the denominator here in the second denominator, and we see that the least common denominator is x plus 3 times x plus 1. But the restrictions, when we set each denominator to 0, is x cannot equal negative 3 or x cannot equal negative 1. So we multiply both sides by x plus 3 times x plus 1, and notice how we distribute. And here the x plus 3 divides through, so we're left with x plus 1. Here in the second one, both divide through, so we write the numerator in parentheses. Don't forget that. That's a common error. And in the last one here, the x plus 1's divide through, so we're left with 5 times x plus 3. So now we redistribute, and again, one distribution at a time. The first distribution should clear denominators. The second distribution is whatever it takes to solve. And we combine like terms. Our answer comes out to be x equals negative 3. However, there's a problem. And the problem is that negative 3 is not allowed to be a number here because it would make the fractions have a denominator of 0. So we have to reject this answer, and our final solution set is the empty set. And that would be our answer. So it's always important to take a look at the restrictions for the fractions, what numbers or values of x we cannot pick. All right, let's summarize now. So let's summarize. To solve rational equations, the first thing we did was to factor all denominators. Next, list restrictions for the variable by setting each denominator to 0. 3. Find the least common denominator of all the denominators. Now, this is very important. Use the multiplication property of equality and multiply each side of the equation by the least common denominator. At this point, all denominators should clear. Then solve the resulting equation and this is very important. Check the restrictions for the variable. So here, this goes back to number 2. If our solution is a value of x which is restricted in the beginning, we should reject it. So this is very, very important, this last step. All right, let's take a look at another one for practice. All right, now this problem is more difficult than the others. We have trinomials in the denominator, and all of them are factorable, whereas in the past 2 problems, only one denominator can be factored. So I'd like you to proceed the same way. This is a more difficult problem, and see what you get. All right, pause your video and restart when you're ready. All right, let's take a look at the solution now. So we factored the denominators here. Let me just point that out to you. So I factored these denominators here into x minus 3 times x plus 1, x plus 1, x minus 1, x minus 7, x minus 1. And looking at these factors and setting them all to 0, we see that the restriction for x is 3, well, x cannot be 3, negative 1, 1, or 7. But we also see that the least common denominator is the product of 4 binomials. These binomials here, x minus 3 times x plus 1 times x minus 1 times x minus 7. So I multiplied each side by the product of those 4 binomials, distributed on the left and multiplied on the right. Notice in the first fraction here, the x minus 3 and x plus 1s divide through, so we're left with these 2 factors. In the second one, these divide through, so we're left with these 2 factors. And in the last one, the x minus 7 and x minus 1 divide through, so we're left with these 2 factors. And here we have no choice, but we have to multiply the binomials out and distribute and put them together. So after doing all that, we get x is 3/5. You could check your arithmetic. I believe that is correct. And 3/5 is not one of the restrictions that we've listed up here, and that is our solution set. Okay, now let's see what this means graphically.
Let's take a look at the graphs of numbers 2 and 3. For problem number 2, our equation was in terms of y, but I put an x instead. X plus 3 over x plus 2 minus x over x squared minus 4. And we get this graph. Notice that this graph has 3 pieces, and there's a vertical asymptote at x equals negative 2 and x equals 2, at which this rational function's undefined. Now, if we look at the graph of x over x minus 2, we have this graph, and notice that this has a vertical asymptote at x equals 2, but they do intersect at this point. And that was our solution set, x equals negative 3. So the So we still look for the intersection points. All right, let's take a look at problem number 3. And that was also in terms of y, but I replaced them with x. The left side of the equation was 2 over x plus 3 minus 3x plus 5 over x squared plus 4x plus 3. And we get this graph. Notice that this graph has two pieces. It has a vertical asymptote at x equals -1, and that's when this denominator, the second denominator, is undefined. And there's an open circle at x equals -3. And if I go to -3, I don't know if I can quite get to it. Very hard to get to the exact place I did before. There it is. We see that at -3, there's an open circle. And that's because if we combine those two rational expressions, that factor of x plus 3 divide through if we put them together. So this graph has a vertical asymptote at x equals -1, and it has an open circle at x equals -3. And we set it equal to 5 over x plus 1. And that's the green graph. It has a vertical asymptote at x equals -1. But notice that they do not intersect at all. So the solution set is empty. The way in which we solved it, multiplying both sides by the least common denominator, effectively we multiplied both sides of the equation by a 0, lead to a ridiculous result. So that would take care of the graphical interpretation.
And this concludes our lesson on rational equations. Have a wonderful day.